Good evening, everyone. So, this is your task 4 class. Okay, so I'll share my screen now and we'll see the code and we'll see the description side by side of your task 4. Okay, so basically, your task 4 is of regression analysis. Okay, and in this, your objective is to build a regression model to predict house prices. Okay, so in this you will learn about something regression analysis, and by making a project which in this will build a regression model to predict house prices. Okay, so in this first thing you have to select a data set. Okay, a data set like housing.csv with features such as area, bedroom and price. Okay, like this you have to select, and then second you have to do task to perform. First is train test split you have to do, then second is train a linear regression model, and third is you have to evaluate the model using metrics like RMSE. Okay, and then the deliverables you have to do is you have to train the regression model, and then you have to make predictions on test data. Okay, so basically this you have to do. So we'll see the code and we'll see the description side by side. Okay, so in this you have to install all libraries. Okay, and you know how to install by using the pip install. By using the pip keyword you can install these libraries: pandas, numpy, matplotlib, c1, skitlearn. Okay, so in this I already told you objective is to build and evaluate a regression model to predict house prices based on features like size, location and number of rooms. Okay, so first we'll see, I'll tell you what is regression analysis. Okay, so basically it's a statistical method to model the relationship between a dependent variable, example like price, and one or more independent variable, example size and rooms. Okay, and in this the concept we are using the regression analysis. Second is linear regression. We are assumes in this, basically it assumes a linear relationship between predictors and the target variable. Okay, and third we'll use the evaluation metrics, which is RMSE. Okay, RMSE is your root mean squared error. Okay, it will measure the model prediction error. And second evaluation metrics will use R square. This is the coefficient of determination. Okay, so this will indicate how well the independent variable explain the variability of the dependent variable. Okay, then we'll do the data preprocessing. In this normalization comes, which scales numerical features to improve model performance, and second is encoding, which convert categorical data, example location, into numerical form. Okay, so now these are the basic concept we'll use, and now we'll see the code and we'll see the concepts also what we have used. So first is you have to import all the necessary libraries: pandas, numpy, matplotlib, cborn, sklearn, this train test, all things which you already installed in the previous task by using machine learning prediction model. Okay, so same libraries you have to import again. Then the same thing you have to do in every task you started with. First is you have to load and explore the data. So I hope everyone knows now how to load the CSV file by using pd.read underscore CSV function. Then you have to some explore the data, head function you are using, info function, and then you will check for missing values. Okay, so pd.read underscore CSV function will load the data set, info function will display column types and non-null counts, is null.sum function will identify the missing values. Okay, now is your handle missing values and outlier step. So first you have to fill missing values. Okay, missing values are filled with the median to retain distribution. Okay, here we are filling with the median. Then outliers are kept using the 95th percentile here. Okay, then you have to handle the outliers part by using the 95th percentile. Okay, so now data cleaning process is also done. Now what you have to do, you have to encode categorical variables. Okay, so here in this you will use one hot coding. Okay, so what is here, you are encoding the location column using one hot encoding. this will convert the categories. Okay, this will convert the categories into binary column. Example, location A, location B. Okay, so this is how it will convert. Now we'll use the normalization. Okay, so we'll normalize numerical features. Okay, so from this first we have to import the min-max scalar from the sklearn preprocessing. Then we'll do the normalization. Okay, so in this normalization scales features to a 0 to 1 range. Okay, improving regression model convergence. Okay, this will do. Okay, then what you have to do, you have to do the feature selection and a train test split. Okay, so here what thing you have to do here, feature X are predictors and the target Y is the house price. Okay, then you have to use train test split. Okay, then you have to use train test split, which is it will split the data. You know, we already did this in the previous task. This will split the data into 80% training and 20% testing. Okay, and then you have to print the shape of both the training and testing set size. Okay, then what you have to do, you have to train the linear regression model. Okay, by initializing and train the model and by displaying the coefficient. Okay, so in this, by using this, the model learns the relationship between predictors and the target. Okay, then you have to make the prediction and evaluate the model. Okay, then you have to make the predictions and evaluate the model. First, you will make prediction on the test set. Okay, then you will evaluate the model. Okay, so in this we'll use RMSE. Okay, RMSE will this will evaluate prediction errors. Okay, lower will be better. Okay, and here R square, this will show how much variance in the target is explained by the model. Okay, closer to 1 is better for this. Okay, then after doing all the things, then last thing you have to do, you have to do the visualize predictions. Okay, so here first we'll plot the scatter plot and then second is the residual plot. So scatter plot will assess prediction accuracy visually. Okay, scatter plot will plot of actual versus predicted price. I hope everyone knows how to plot a scatter plot. Okay, and then residual plot checks for normal distribution. Okay, and the equal variance. Okay, so for this we'll plot a residual plot. This is also a part of the advanced plot, which is Seaborn library. You have to use sns.hist plot function, and here you'll use residual kd is true and bins is 30, color we have set blue. So this is how you have to make a residual plot, which will check for normal distribution and equal variance. Okay, so basically deliverables is you have to train the model, the regression. This regression model predict how house prices based on features. Then you have to use the evaluation metrics. RMSE and R-square provide quantitative evaluation here. Okay, this, and then you have to visual the insights. Okay, so actual versus predicted prices shows the model accuracy, and then residual distribution validate the assumption for regression. Okay, so this is what you have to do in your task 4, which is of regression analysis. Import necessary libraries, load and explore data, handle missing values, encode. Then you have to do the normalization, then you have to define features and target variable, then you have to initialize and train the model, then you have to make predictions on the test set and evaluate the model by using RMSE and R square. Then you have to do the visualization for the insights. You have to make a scatter plot and a residual plot. Okay, so this thing you have to do in your task 4. So I hope it's clear. If not, then you can ask me any doubt in the chat box right now. So is this your task 4 is clear to you all what you have to do? Is it clear? Yes or no, is it clear? Yes. Okay. So please complete and submit your task on time, and if you face any doubt related to your task, you can ask me in the Telegram group, that discussion group. Okay. So please do your task and submit your task on time. Okay, and if you have any any more doubt left, you can ask me in the chat box. Else, those people don't have any doubt, they can leave. The class is over and we'll see you next task then. Okay.